And today I'm going to present to you modeling language that helps us derive security requirements for socio-technical systems. For starters, I want to introduce you the concept of socio-technical systems. So, what are these systems we are considering for the modeling language to help us elicit security requirements? Generally, the term socio-technical system refers to an interplay of different subsystems in which we have components that are not only technical, like software or hardware components, but mainly we have the involvement of humans and organizations. The systems exist primarily because these different subcomponents are autonomous and they can achieve a lot of things on their own, but they also need to interact with others to get other things done for those that they cannot do on their own. So the system per se is defined in terms of interaction among the subsystems because each of them needs to socially rely on others to get its objectives done. To give you an example, examples of socio-technical systems include smart homes, in which, for instance, imagine you have patients or elderly who need healthcare to be given. You have healthcare givers, nurses, doctors, and you have a set of sensors in the environment that would help the healthcare givers to get input on the conditions of the patients or what is happening in the environment. So all the system exists because each of these components relies on others to get information or interact with others. For instance, the healthcare givers to get input from the sensors, and the elderly or the patient to get care from the healthcare givers. I've taken also another example, like a more concrete one. Consider a scenario in which a researcher would come to the University of Trento to give a talk, a seminar, or a lecture. Suppose he's coming from somewhere else, so he's not from Trento, and to come all the way here, he would have to deal with managing the traveling and have a trip booked, basically. In this scenario, we have the visiting researcher, and suppose he's not booking the trip on his own, but he's relying on a travel agency. So in order to get the trip booked, he's relying on Chip Travels Incorporation, which will deal with finding an appropriate flight itinerary for him and also to book a hotel. We see here that the Chip Travels Incorporation deals with a given flight service, the Amadeus flight service, to offer possible itineraries to the researcher to arrive all the way to Trento. And the Amadeus flight service, on the other hand, deals with different airline companies in order to find the appropriate itinerary and to find one that can be affordable, or let's say a low-cost one perhaps. In this scenario, I've considered that the Amadeus flight service interacts with the Lufthansa airline company services and Alitalia in order to provide an itinerary to the researcher. On the other hand, in order to book a hotel, again, the travel agency is interacting with different hotels in the city in order to check room availability and to find a room for the designated dates that the researcher might need. On the other hand, all this chain of interaction starts because the primarily purpose of the researcher is to come to Trento and to give a talk, and this is set because he interacts with the university to set a seminar date and to establish all the logistics to come all the way here. And all these errors that you see are basically the interaction between the different components in the system, so because they have to rely on others. So for instance, the travel agency on its own wouldn't have all the information about flights if it didn't rely on a given flight service. It could be another one. This is just for the scope of the example. On the other hand, the flight service would not have any input if it didn't interact and rely on the different operating airline companies. And the same holds also for finding a hotel. Our purpose is basically on dealing with security in socio-technical systems. You saw that interaction is everywhere. It is between technical systems, like in the case of the Amadeus flight service when interacting with the different services of the airline. Companies, it happens between technical systems and social actors, such as in the case of the travel agency when interacting with the Amadeus flight service, and it occurs between social actors, such as in the case of the visiting researcher with the travel agency or the visiting researcher with the university. And our scope is to make these interactions more secure so that every component can rely on others, knowing that its objectives will be achieved, and these interactions won't be vulnerable to any security issues. And the focus here is mainly on social aspects because we are operating on a decentralized setting, so we're not within the safe boundaries of one single closed system in which you'd have a controlling authority that assigns who does what and how. But basically here all the components are autonomous, so security cannot be enforced in that way. And the key idea of our language is that we use social contracts to constrain interaction. Interaction that mainly occurs in two ways: social dependence, as you saw, and when socially relying on others, very often the different components also exchange information, and also information can be prone to many security issues. So the language is the Socio-Technical Security Modeling Language. Briefly, we refer to it as STS-ml. It's a role and goal-oriented requirements modeling language. It's an extension of Tropos. Perhaps you've already learned that. And it's a graphical language, so models are built diagrammatically, and it has graphical concepts and relations that are used to create the models. The particularity of this language is that it offers multiple views in the sense that you don't have to build the whole scenario building one single big model, but the model itself, it's separated in different views, in which you concentrate on a particular perspective at a time, but we'll see it in the following slides. And on top of that, we allow the different interacting components, to whom we refer as actors, to express security constraints that they have over interactions they participate in, and we call this security needs. So for instance, as I said, we have these two main forms of interaction: social dependence, which comes in the form of goal delegation. So for instance, when the visiting researcher depends on the travel agency to book the hotel and the flight tickets to come all the way here, he might require the travel agency to not deny having accepted the delegation. That would be a non-repudiation security need. It also might require the travel agency to deal with achieving all these objectives on its own, say because it doesn't trust any other parties that could be involved in the system. So these are the type of security constraints that one could express when entering an interaction with another party. On the other hand, information is what mainly we would like to protect and not allow others to manipulate as they like. So for instance, say when the visiting researcher wants to book a flight or to book a hotel, he would have to provide to the travel agency a copy of his passport, so to say, or an ID document that it's needed in order for them to book the flight or the hotel. But he might want to express that he wants this information to be strictly used for the scope of booking the flight or booking the hotel, not for any other reasons. And moreover, he might require that this information is not disclosed to other parties, so it's kept private by the travel agency. So this is yet another set of what kind of constraints the different interacting actors can express to others when entering in interaction with them. To give you a general outline of the language, as I said, it's a multi-view modeling language. It has mainly three views. The social view, in which we represent actors and their interactions. The information view, in which we capture the informational content of all the documents that actors can exchange while interacting and their structure. And finally, the authorizations view, in which we represent all the permissions and rights that actors grant to other parties they interact with on what they can perform over the information. The whole view is called, so the whole model would be represented in the operational view, which is the set of all these three views together. And we allow the expression of security needs of the kind that I just explained through the example. And once the modeling is done and all the security needs are captured as we talk with the stakeholders, we can automatically derive the set of security requirements for the given socio-technical system that we're trying to design. Then the language has tool support. This is automatically derived by the tool. Once the modeling is done, all the security needs are expressed. And in the end, we can also generate automatically a security requirements document that explains more in detail all the scenario or the system that is being built and the set of security requirements it has to satisfy in order to be secure. Okay, let's go more into detail so that you get a more concrete look on how the language operates. So this is an outline of the method on how you can model different scenarios or systems with this language. It involves 5 main phases in which we model the different views. So in the first phase, we model the social view. And this consists of 4 main steps. For starters, we want to identify who the stakeholders operating in the system are, and then we want to identify their assets and the interactions they have with others. We want to capture the security needs they have while entering these interactions. And finally, we want to see if there are any threats that are influencing or affecting the stakeholders' assets. On the second phase, we model the second view that is supported by the language, the information view, in which we identify information, the information content of what is contained in stakeholders' assets, their documents mainly, and who are the owners of this information. This is important because basically the owners are the ones who are concerned with what happens to their information. And this view also helps us represent the information structure, so what information is contained in what document, but we'll see that in a while. In the third phase, we model the authorization, so the focus here is in the third view, in which we capture all the passage of permissions from one actor to the other on what they can perform over information. And here again, we express a set of security needs that are related to information and their manipulation. Of course, these modeling activities are shown on this order, but basically refinement will take place till the moment that the designer, together with stakeholders, decides that the model has arrived to the level of granularity and detail that captures everything they want to capture for the given system, and all the security needs are expressed. Once this is done, through the tool we provide automated analysis, which basically performs 3 different verifications. At first, it checks that this is a way to help also the designer when building the graphical models, because this can become big and huge, most probably. So at first, we help the designer to check if the models are consistent, so if they're following the semantics of the language. Then for all the security needs that have been expressed over the models, we want to verify if they can be satisfied or not in the system. And then we want to check if all the threads that we've modeled in the social view affecting the different assets, the stakeholders' assets, how they influence the rest of their assets. So threat propagation is handled in this third phase of automated analysis. And finally, once we've dealt with all this, we can derive the set of security requirements and generate the security requirements document. So now I'm going to go through all these phases in detail so you can see more closely what is performed in each step. So in the first phase, as I said, we identify stakeholders. In our language, we support representing stakeholders through the concepts of agent and role. Then we want to identify their assets and interactions. With assets, we refer to the goals or objectives the actors have and the documents they possess and exchange with others. And interactions in this view are captured by two main relations: goal delegations and document provisions. In the third step, we allow the expression of security needs. Mainly, these are expectations concerning security needs that are expressed exactly over these interactions, goal delegations and document provisions, and these are elicited by the stakeholders. So the designer would express this over the model after talking to the stakeholders. And in the fourth step, we model threats, which represent events that are threatening stakeholders' assets. This is the representation of the scenario that I introduced you in the beginning. So for a more general purpose, I've referred here to the researcher as a tourist, because the scenario would apply to any traveler going somewhere while interacting with the travel agency service, and travel agency service would be interacting with different flight services. In this case, we have the Amadeus flight service. This picture here is just to give you a flavor of how it looks like modeling a given scenario. This would be the social view for our example. This concept here, hotel, is a role, and these are the different goals that the actors have. We represent in terms of agents, all the participants that we already know at design time, and with roles, the ones that we don't know exactly how they're going to be instantiated at runtime. Goal delegation is represented in this way, and document provision is represented by this relation between the two actors while providing the document. So, in the first step, when we identify stakeholders, we need to elicit roles and agents. And as I briefly mentioned, a role refers to, basically, think of it as a class that can be instantiated at runtime. So it's an abstract characterization of the behavior of an active entity within the given context. So when we are building these models are built at design time. And most probably all of our actors would be represented in terms of roles, such as, for instance, tourists, but we don't know if tourists would be Elda or any of you. Travel agency service, but we don't know which travel agency service this particular tourist is going to select, or the hotel, and again, the same applies here, which hotel will be instantiated that role. Whereas we use agents for those actors which we already know at design time. So for instance, agents refer to concrete entities operating in the system. So it would be Elda, Fabiano, Chip Travels Incorporation being this given, known travel agency in the system. And some of these agents are known. So for instance, we know already from our stakeholders when trying to build the system that the Chip Travels Incorporation always relies on the Amadeus flight service to book flights. Therefore, we can represent that in terms of an agent. Once we have represented all the actors, captured all the stakeholders in the system in terms of roles and agents, we go then within a given actors model to identify what are the objectives, because starting from their objectives, we can then decide what are the objectives they can achieve on their own and what are the ones they need to rely on others to get these objectives done. So a goal is mainly referred to as a state of affairs that an actor intends to achieve. So for instance, examples of goals include trip planned or having flight tickets booked and so on. So they're used to capture the motivations as well as the responsibilities of actors. In order to represent how goals could be achieved, very often we need to further refine them, so to see how we can accomplish a given high-level goal, say tickets booked or trip planned. The language offers two possibilities. The first one through order compositions, which captures alternative ways of achieving the goal, meaning that in order to have tickets booked, the travel agency would either book train tickets or book flight tickets. This order composition is under the assumption that the destination could be reached in both ways. On the other hand, in order to capture the process of how a given goal is achieved, we use end decomposition. So end decomposition dictates that this goal will be achieved by achieving tickets booked and hotel booked. So both of them need to be achieved in order for the trip to be planned. As I said, actors might have capabilities to achieve some of these goals on their own. So you'd have these goals within an actor's compartment and then deal with goal achievement, but very often they cannot achieve goals on their own, so they need to rely on others. And we capture this concept of reliance through goal delegation, which captures this relation between two actors, the first being the delegator actor, the one that delegates the fulfillment of the goal, to which we refer as delegatum, to a different actor. So the second actor is the delegatee. So for instance, here we assume that the tourist is not capable of booking the tickets on his own, so he needs to rely on a travel agency to achieve this goal. And this delegation is represented in this way. So the relation from the delegator, being the tourist, to the delegatee, being the travel agency service, for the given goal, tickets booked. In our language, we allow only leaf-level goals to be delegated. So anytime, for instance, you would like to capture that the tourist might rely on several travel agencies for this goal, then you'd have ticket booked or decomposed into ticket booked by the first travel agency and tickets booked by the second agency, and then delegate these leaf goals to the interacting actors. When the actors operate in a given system, they possess documents and manipulate documents to achieve their goals. Here we identify different operations that actors can perform while achieving their goals. So an actor may need to use or read the informational content of one or more documents while fulfilling a goal. An actor may create or produce a new document while fulfilling a goal. And finally, an actor may modify a document while fulfilling a goal. So here I've taken the example of goal flight ticket booked, which once fulfilled creates the flight tickets. So the fulfillment of these goals would lead to the creation of this new document, but it needs the information about the itinerary details. So in order to book the tickets, you need also when are these tickets going to be used, or in case the tickets need to be modified, you need to modify this information in order to get the right flight tickets. As I said, actors possess some documents, but for others they need to rely on other actors to provide these documents to them. And we capture the exchange of documents between a provider actor and a providee actor through the relation of document provision. So this is an example of document provision. When the tourist is relying on the travel agency service to get the trip booked and to book the flight tickets, it has to provide to the travel agency information about the trip that it wants to organize. So we present this document, traveling order, which needs to be provided to the travel agency in order to fulfill the goal that has been delegated by the tourist. Here, in the language, the restriction is that an actor can provide a document that it possesses. So if it doesn't possess the document, it cannot provide a document it does not have. And the provider most probably is an actor that needs these documents to achieve the goals that it has, or goals that has been passed by somebody else through a goal delegation. On the third step, once we have represented the actors in terms of agents and roles, captured their objectives and their interactions, we then focus on the interactions and want to capture what are the security constraints that these actors have. We support a set of security needs in our language. One of them is non-delegation, which specifies that when delegating a given goal, when an actor delegates a given goal to another actor, it might want this actor not to further delegate this goal to any other actors, but to achieve this goal on its own. So redelegation of this goal is forbidden. And this is represented in our language through this dashed arrow line, and also just below the goal, the delegated goal, we have this rectangular with no D for no delegation. This could be a security constraint that an actor wants to express because he might trust only this given entity but no other actor operating in the system. On the other hand, in order to have a secure interaction between two parties, we support the security needs of non-repudiation. It can be expressed by both interacting parties. So when TAS relies on the Amadeus flight service to have flight tickets booked, it might require the Amadeus flight service not to deny that it has accepted the delegation, but at the same time the Amadeus flight service could express the security need of non-repudiation to the TAS so that it doesn't deny later on that it has delegated this goal to the Amadeus flight service, so that he doesn't achieve a goal that he supposedly was not delegated by anyone. Similarly, we express over interactions other security needs. So one of them is minimum trustworthiness level. This indicates that a given actor will delegate only to actors that satisfy a minimum trustworthiness level. So the delegation will take place, in this case, only if the trustworthiness level of the hotel is above greater than 7. On the other hand, one actor might specify that when relying on a given actor, it's like this is similar to an interaction between a service consumer and a service provider, the first requiring the second to provide a minimum availability level for the services that it is providing. So availability indicates that the delegated should ensure a minimal availability level for the delegated goal. In this case, I have considered a minimum availability level of 85%. Moreover, in our language, we support also the security need expressing redundant ways to achieve given goals. These are important, especially in critical settings, such as, for instance, air traffic control management, when we are concerned not only about security, but also about safety, and we want more ways to be sure that things will be achieved in the end and our interactions are not vulnerable. So redundancy refers to these alternative ways of achieving a given goal, and we distinguish different redundancy types. True redundancy refers to having multiple concurrent ways of achieving a given goal. So in that case, you'd have, for instance, the actor decomposing the goal into at least two or sub-goals and achieving both of them at the same time, not selecting one or the other. Fallback redundancy, on the other hand, refers to having one primary strategy that is followed to achieve the goal, and if that fails, then another one is selected. And while dealing with redundancy, one still could have trust issues and specify that it wants only the interacting actor to achieve redundancy, and we refer to that as single actor redundancy. And when it wants that actor and at least another actor, so more actors, we would have a multi-actor redundancy. And having the combination of these categories, we can distinguish four different types of redundancy: true single, true multi, fallback single, and fallback multi. Anyway, the redundancy is specified again over goal delegation and would be represented down here. Next time when we will go through the tool, you'll see in practice how we can distinguish from the different categories. Apart from this security needs that actors express over the interaction, so these are constraints that a given participant is expressing to other actors he's interacting with, there are other security constraints that derive mostly from rules in the organization or the system we're operating, and we refer to this as normative constraints. And in our language we support two of them through these relationships of combined and incompatible. Basically, this refers to norms such as binding of duty, which requires that, for instance, two roles need to be adopted in combination by any actor operating in the system. So whenever such constraint is specified, it can be specified between two roles, then it says that one actor adopting one of the roles, it has to adopt also the other role as well. On the contrary, incompatibility expresses a separation of duty constraint, meaning that when it is expressed between two roles, it says that any actor adopting one of the roles cannot adopt the other one. And similarly to the expression of these constraints over roles, we express them over goals, as shown in this example here. So for instance, we have a separation of duty constraint incompatible, which is expressed by this sign, saying that whenever an actor is achieving one of these goals, it must not achieve the other one. So it has to be two different actors achieving these two goals. Whereas the binding of duty, the combination, would be represented through an equals sign, and it would specify that any actor achieving one of the goals, it has to also achieve the other goal. Apart from the constraints of goal delegations, and as we saw between different goals or roles, we have also security constraints of document provisions. So for instance, integrity of transmission expresses that a document should not be altered during the transmission from the sender to the receiver. And this is basically expressed by the receiver, who wants the integrity of the document that it is being provided to him not to be altered. So he wants the integrity to be preserved. To give you the overall view of how the security needs are expressed in the social view, starting from the scenario we show at first, we capture through all the different interactions the security needs of actors' interaction. So, for instance, the tourist is expressing a non-repudiation security need when delegating tickets booked to the travel agency service. It is also requiring the travel agency service to satisfy a no delegation security need and the redundancy security need. On the other hand, TAS is when delegating flight ticket booked to Amadeus Flight Service is specifying non-repudiation, no delegation, which is also shown by the dashed airline, as well as a minimum availability level. As you see, the different security needs are distinguished one from the other through the usage of different colors, so that one can see that there are more security needs expressed. And these rectangles are shown just below the goal delegations or document provisions. So the integrity security need is expressed over document provision of itinerary details from the travel agency service to the Amadeus Flight Service. We have an example of trustworthiness expressed over the delegation of hotel booked to the hotel and a non-delegation security need. And in terms of compatibility or combination and incompatibility, we have expressed the separation of duty constraint over the goals room selected and prepayment made, specifying that these two goals should not be achieved by the same actor. Whereas here, between goals ticket booked and hotel booked, we have specified a binding of duty constraint requiring the same actor achieve these two goals. So it is in this way that we represent actors, their goals, the documents they need to manipulate through these operations, need, modify, produce, and provision to exchange documents, the transfer of responsibility of achieving a given goal to actors that can do it on one's behalf, and the expression of security needs. So that would conclude what we do in order to capture stakeholders, their assets, and the security constraints they want to express over interaction. But as I mentioned in the beginning, we want also to see whether there are certain events in the setting that could affect the well-functioning of the system and would affect the interactions among actors. We express these events as threatening goals actors want to achieve, or documents they might need or possess to achieve their goals. So, for instance, when expressed over a goal, a given event could specify that the goal cannot be reached, and we want to see that if this given goal is threatened, how it would affect the rest of stakeholders' assets and his interactions. On the other hand, threats could affect documents, specifying, for instance, that the document would be no longer available, so the actor would not possess it, and this would also entail a certain number of consequences over the actor's assets and interactions. With this, we conclude the modeling of the social view. To proceed with the second phase, modeling the information view, in which, as I said, we want to identify information and its owner. Because in the social view, we have actors exchanging documents with one another, but these documents contain information that could be confidential. So in this view, we want to see which is the informational content of the documents that actors exchange in the social view. And so here we have the representation of documents which are preserved from the social view. The actors, stakeholders, who are also preserved from this social view together with their documents, and here we represent information and say who are the owners of this information. Moreover, we represent also information structure. So, as I said, which is the informational content of a given document? So, which document represents an information? We represent that through the tangible by relationship. And also, we use another relationship, part of, to say that a given information piece is part of a bigger information piece, and a given document is part of another document or document bundle. Here is the information view for our example. So the tourist has document ID, document copy, which is part of traveling order, who has a set of documents. He owns the information regarding his personal data. You see, information is represented in terms of a rectangle with a dashed line to be distinguished from the rectangle used with a continuous line for documents. Ownership is represented by this double-headed arrow from the actor owning the information towards the information. An actor might own more pieces of information, as in this case. Tourist owns personal data and itinerary information. This information is represented in given documents, so a given information piece could be made tangible by more documents, as in this case personal data is made tangible by both ID-doc copy and e-ticket, which is the flight ticket generated once the flight tickets are booked. On the other hand, itinerary information is made tangible by both traveling order document and itinerary details. As I said, part of capture the structure of information. So itinerary information, we assume it's composed of information regarding destination and schedule. So this information pieces are considered to be part of itinerary information. This view is as an intermediate passage view from the social view to the authorization view, in which we capture the passage of permissions from actor to actor regarding the information they own or possess and have authority to pass rights to others. So in this third phase, we model the authorizations, the transfer of rights between actors. Authorizations in our language are quite specific and explicit, as they specify the scope of usage. This refers to a set of goals for which a given actor can manipulate a given information. So this is under the assumption that one actor would not grant authority to another one over his information for anything. You would provide this information and grant certain rights for a particular scope. So in the case of the tourist would permit the travel agency to use his personal data only for the scope of booking the tickets, but not for any other purpose that the agency might have, such as to say for publicity use or for statistical analysis. So he wants his data only to be exploited for the purpose that he wants to achieve. We also specify through the authorizations the allowed operations. So what can the other party perform on the information I'm authorizing him to do? The operations we allow in the language are a one-on-one map to the operations actors can perform while achieving their goals and using, modifying, or producing the documents. So the allowed operations are use, referring to need relationship in the social view, modify, referring to modification relationship in the social view, produce, again, referring to a produce relationship between an actor's goal and a document. When creating a new document, he is producing new information, and distribute refers to the action that actors are distributing information, and since in the social view we said that actors exchange information by means of document provision, distribute refers to actually document provision between actors. Moreover, in authorizations, we have this third property, that is transferability, which would grant an actor a higher level of authority. So apart from allowing operations one can perform, the owner or an eligible actor is granting the authority to further propagate rights to other actors. So this entity would become eligible as the owner itself to further propagate rights to other actors for those operations he's been authorized. So this is the authorization view for our example. In the authorization view, we preserve information about who is the owner of information. In this small scenario, we have just one actor who is owner of information, and then we capture how authorizations are granted starting from this actor to the other ones. So this information is preserved from the information view, the tourist being the owner of itinerary and personal data, and itinerary being composed of destination and schedule information. Here you can distinguish these three properties of an authorization relationship, which we can consider as three different slots. So the authorization relationship is represented in this way, from one actor to another actor, showing the direction of authorization being granted, representing which are the allowed operations, so what operations this actor can perform, representing the information in the second slot, so for which information this authorization is being granted, and also representing the scope, so for what purpose is this authorization of this information being granted. So in this example, the tourist is authorizing the travel agency service to use, so this refers to use, modify, produce, and distribute operations, and if selected, they're shown in yellow, whereas the rest are not checked, so this authorization is not granted to the other party. So the tourist is authorizing travel agency service on his personal data and itinerary information that he owns for the scope of ticket booked. So the TAS can use this information in order to achieve tickets booked. On the other hand, TAS is also granted the authority to further transfer rights, and this is captured by the continuous line, as opposed to having a dashed arrow line indicating that the travel agency service is authorizing the Amadeus service to perform these rights over this information for the scope of this goal, but the Amadeus service can just perform these operations. It's just allowed to perform these operations, but he cannot authorize other actors on this information for these operations. Similarly, the authorization from the tourist to the hotel. And in the authorization view, we also can elicit yet another set of security needs, this time related to the manipulation of information. Differently from the social view, in which we explicitly express the security needs, represented with those small rectangles below the goal, delegation, document provision, or between goals and roles, here we represent them in an implicit way. So a security need is expressed by allowing only certain operations and limiting the scope. So anytime we define a scope, and here I have to say that we could leave also the third slot could be empty, and in that case it means that the actor is allowing the other actor to perform operations for any scope, so it's not limited to a given goal scope. But when we do limit the scope, then the actor is requiring that this information is manipulated only for that scope, not for any other reason, requiring a need-to-know security need. And for each operation that is allowed or disallowed, not allowed, we can derive yet another set of security needs. So when the usage operation is not allowed, so it's not granted, the first actor is requiring non-usage of that information. Similarly, when modification is not allowed, then the authorizer is not granting to the authorizee modification, so it's requiring him non-modification of that information. And the same applies to produce and distribute. Referring to the example, so whenever distribute is not granted, a non-disclosure security need is required by the tourist to the travel agency service, requiring that the TAS does not distribute, does not provide any documents containing personal data or itinerary. So this information will be made tangible by these documents. So any documents representing this information cannot be provided to any other actors. Whenever M is not granted, then non-modification security need is required, stating that hotel cannot modify any documents representing personal data. Similarly, whenever P is not granted, so production is not granted, a non-production security need is required, so TAS cannot produce any new documents or any documents that represent personal data or itinerary. Whereas need to know is related to limiting the goal scope, so the hotel can use tourist personal data only for the scope of booking the hotel, but not for any other goal. As I said, once we build the models, we want to help the designer to see whether the models are consistent, so there are no wrong relationships, like the model follows the semantics of the language. So there are, for instance, no cycles between goal delegations or between part of relations and so on. Secondly, we want to verify whether all the security needs that have been expressed can be fulfilled in the model setting, or if there is any inconsistency between the different security needs. For this, we have the security analysis that can help us. And lastly, we want to see the impact of the events that threat stakeholders' assets. In the first step, we can see whether there are any consistency problems. So here I've given an example of a hotel delegating hotel book to a hotel service, and then the hotel service is further decomposing this goal into room selected and prepayment made, and redelegating back room selected to the hotel. We consider this as a warning to be given to the designer, because we assume that the hotel does not have the capability to achieve this goal on its own, so for that he's relying on the hotel service. But if the hotel service is redelegating back, we want to check if that is okay or not. So we give a warning to the designer. And we have a number of checks that we perform, such as, for instance, single goal decompositions. We support goal decompositions of a goal, refining it into at least 2 sub-goals. So a single goal decomposition would be an error. Leaf goal delegation checks that the designer has actually delegated a leaf goal. As I explained in the beginning while talking for goal decomposition, we do not allow delegating, for instance, hotel book, but we allow only delegation of leaf goals. And so on, we have a number of checks. For instance, ownership. The check about ownership, we want to check that all information have an owner, so that we can then reason if this information is manipulated in an authorized way or not. And when it comes to authorizations, we don't want to have empty authorizations or authorizations that specify no information because they don't express anything, basically. And we then, once we assure that the model is consistent and all the model is correct, we want to see if the security needs that have been expressed by the stakeholders, the interacting parties, are satisfied or not. So to give you an example, when the tourist is delegating hotel book to hotel and is requiring no redelegation of this goal, captured by this dashed arrow line, he wants the hotel to do this goal, to achieve this goal on his own. But then we see that the hotel is actually relying on a hotel service to have a hotel booked. So redelegation is actually happening, and this might be because the hotel usually operates in that way. So the security analysis would capture this as an error, indicating to the designer that either one of these needs to be relaxed. So either the hotel does not rely on other parties and achieves the goal on its own, or the tourist has to accept that the hotel usually operates in this way, relying on a third-party hotel service to have hotel booked. When it comes to threats, we want to see how a given threat that we have modeled affecting goals or documents affect the rest of stakeholders' assets. So for instance, when we said that this goal could be unreachable, so if train tickets booked is threatened, then if this goal is not achieved, then also the document that it is producing after the achievement of this goal would be affected. And also, if we assume that the travel agency service would select this alternative to have tickets booked, also these, the further goal would be affected. On the other hand, when we consider threats to documents, we want to see again how it affects the rest of goals. So for instance, when ID doc copy is threatened, also the goal that needs this information in order to be achieved would be threatened. And similarly, would see the propagation to all the rest of stakeholders' assets through their interactions. Following our steps, we come to the last phase, in which we have assured that the models are correct and the models are consistent and the security properties that have been defined can be fulfilled. We now can derive the consistent set of security requirements for the system we are trying to design, so that these express the protocols the actors need to comply with for their interactions to be secure. These requirements models are also useful when we are communicating with the stakeholders, because they tell the designer what the system has to implement. In our language, the security requirement specification are automatically derived from the requirements models once the modeling is done and all the security needs have been expressed. And we can generate, as I said, a security requirements document that gives overall detail about all the stakeholders, their interactions, and the security needs they have to comply with. How do you do that? All the security needs basically capture constraints that one actor wants the other actor it is interacting with to obey. And we capture security requirements in terms of contracts between the two parties. So the first being the one who requests the security need, and the second one being the one who accepts it, and when it accepts the security need, it has to obey and comply with it. And the requirement would actually be this contract between the two. So for each requirement we have a requester, the requirement itself representing basically the security need or the constraint that is expressed, and the responsible actor being the second one who will obey to this constraint that has been specified. So for each security need that we have expressed from one actor to the other, a requirement is generated on the opposite direction from the responsible actor to express a compliance with the security need that is being required. How we do that? So whenever we have security needs expressed over interactions, say non-repudiation, redundancy, availability, integrity of transmission, and so on. For instance, consider non-repudiation expressed by the tourist towards the travel agency service. The tourist is the requester actor who's requesting non-repudiation of acceptance because it wants the travel agency service to accept, to not deny that it has accepted this delegation. So the TAS is the one responsible for satisfying this requirement. Similarly, if the TAS has expressed a non-repudiation of delegation, so the tourist cannot deny it has actually delegated this goal, then the tourist is responsible to satisfy this requirement. If we consider redundancy, or for instance, no delegation, to refer to this example, when the tourist expresses no delegation over this, when delegating this goal to hotel, the hotel is the party that is responsible to satisfy this requirement, whereas the tourist is the requester, as shown also here in this table. So the hotel is the responsible party to satisfy no delegation. Similarly, we do for all the security needs that are expressed. The particular one are the normative constraints, so separation of duty or combination of duty, which specify, for instance, when expressed between goals, as in this case, e-ticket generated, credit card verified, we have separation of duty expressed between these two goals. It requires that any agent operating in the system does not achieve both e-ticket generated and credit card verified. And the requester we consider here to be the organization, since this is something demanded by the rules of the organization or the system that we are building. As a second set of security needs that we support are related to authorizations, we now generate also the set of requirements that are derived by modeling the authorization. So, for instance, when we consider the authorization relationship between tourist and TAS, the tourist is only granting usage, but not modification, production, and distribution, and also it's limiting the scope. So basically here we have 4 requirements, 4 security needs that are then translated to requirements expressed by the tourist to the TAS: non-modification, non-production, non-disclosure, and need to know, which we can generate in this way. So TAS is the one responsible for complying with these security requirements. So TAS has to comply with need to know of personal data and itinerary information to be used only for tickets booked as requested by the tourist. It has to comply with non-modification, non-production, and non-disclosure of both this information. Similarly, we would generate all the requirements for all the different authorizations that are being granted. One being also non-transferability. So whenever a given actor is not authorized to transfer authorizations to others, then he would have to comply with the requirement for not reauthorizing other actors. And for the rest, with operations and scope limitation, we would have similar requirements, but the responsible actors would be the authorizees for each given authorization modeled in the setting. So this is how we can conclude all the steps, all the phases of the modeling method supported by STS-ml. We have modeled all the different views, captured all security needs as expressed by the stakeholders or as required by rules or norms that are in the system. And we have tool support for the language, which is named STS tool, Socio-Technical Security Tool, and it is the modeling and analysis support tool for STS-ml. It's a graphical tool as the language, and you could see here some snapshots of the different views, but we'll see next time having a hands-on session, so please bring your laptops. And it's a standalone tool and is built on top of Eclipse. It's freely available for download. Next time we'll download it live, or if you want you could download it for your operating system from home. And it allows modeling, it supports all the different types of analysis, as we mentioned, the consistency, security, and threat propagation. And in the end allows derivation of security requirements document, but we'll see this live next time. Thank you, and see you next time.